day, viewers. You are welcome once again to another interesting time with Jot Tutors. We believe you are following our videos because we are very sure it will be very helpful for students in high school. Today we continue with Euclidean geometry, and today we just want to treat some questions that might be somehow challenging to the student. All right, this is a question. In our last video, please try to get it. We discussed some of this theorem of circle and their applications. We treated some of the questions too, and today it's an extension of what we started in our last video. The question says, O is the center of the circle, and SPT is a tangent with OP perpendicular to ST. We can see it is perpendicular to ST, line ST. ST is the tangent, SPT is the tangent. Determine A, B, and C with reasons. As I have told us earlier, that anytime you are solving questions under Euclidean geometry, you must give your reason why the answers are so. And also sometimes when you are solving these questions, it doesn't have to follow it alphabetically, but you have to solve it reasonably just to get the answer that are required. All right, in solving this question, if we look at this question, we have a B that corresponds to 64. If you can remember, one of the theorem is a tangent chord theorem. Please get our last video, it is there. So my B is going to be 64, and the reason is tangent chord theorem. The tangent chord theorem. Okay. For A, okay, before A we can look for C. We can look for C because if you look at C, angle C and angle B are subtended by the same chord, and they are subtended by the same arc. They are subtended by the same arc, and they are subtended by the same chord. And in one of the theorem, we are told that angle subtended at the center is twice angle subtended at the circumference. So C is going to be 64 multiplied by 2, which is going to be 128 degree. And the reason is angle at center equals to twice angle at circumference. You can abbreviate it and you are going to get your full mark. Okay, now that takes us to A. And if you look at this diagram, A is actually subtended by the same radius. Can we see it on the dotted line? And if we have the same radius, definitely my angle PON is going to be an isosceles. It's an isosceles triangle. So if it is an isosceles triangle, my C, I've already gotten it to be 128. That means whatever I have here and this one must be equal. Both of them must be equal. So if I subtract 180 minus 128, I'm going to have 52 degree. And I can divide the 52 degree by 2 because these angles are going to be equal. So, and the remaining angle left for the two of them to share is 52. It's going to be 26 degree. And we can put there that is an isosceles triangle. That is the reason. So that is for that. Very simple. As I've said earlier, Euclidean geometry are very simple. Let's try another question. Look at another question. This question says QTS are points on a circle. We can see it in the diagram with center O. Okay. Determine angles for R, Q, and P with reasons. Okay. Very quickly, if we look at this structure, we can see that this triangle is actually within the framework of a semicircle. So if I want to get my R is definitely going to be 90 degree because it is an angle in a semicircle. Very simple. Please just get yourself familiar with this theorem and practice as much question as you can, and I tell you, you will be very good in Euclidean geometry. Okay, the second thing we can look at is the Q. If we look at the Q, it has the same corresponding angle with the tangent, the opposite side of the tangent, which is 52, and we can put the reason as the tangent chord theorem. Please look for this theorem and get used to them. And the last question there is P. Angle P, we know that the total angle in a triangle is 180. So, and we have gotten R, we've gotten Q, then we can look for P. So P is going to be 180 minus 90 plus 52. If we resolve it, we are going to get 38 degree angle in a triangle. That is it, and those are the reasons. If you do your solutions this way, you can be very sure that you are going to get your full mark. Okay, let's try one more question before we end this video. Thank you. All right, we are looking at the last question in this video, and the question says A, B, C, and D are points on the circumference of a circle center O. AC is the diameter of the circle. You can see the AC, all right? And ABD, angle at B, you can see it is 58. CDB, angle at D is 22, all right? The question now says, find ACD. ACD, angle at D. ACD, and is the same thing as the one, C1. You can call it the C1 as identified in the diagram, C1. And we are also asked to find ACB. ACB, angle at C, which we can call C2. All right, let's deal with this. Before we go on, there are some preliminary studies that I will expect us to do. And how do we do that? We can identify some angles that are going to help us in solving this question. Let's say, for instance, my C1, which is the ACD, is in the same segment with my ABD. Can we see that? You see, this angle is in the same segment as this. I used to tell my student that there is a bow tie that should be identified in an Euclidean geometry. All right, so C1 is going to be 58, and the reason is angle in same segment. Angle in the same segment, they are always equal. Okay, now we want to look for C2, which is the ACB, angle at C, and we identify it as C2. First and foremost, let's quickly do some little analogy. Angle in the same segment also to the down part are equal. That is, this angle is the same thing as this angle. So I can call this one 22. I can call this 22. Yes. All right. Then also, we can identify that this triangle is a semicircle. The triangle is a semicircle. Very simple. Euclidean is one of the most easiest topic I've ever known in mathematics. Can we see? It's a semicircle. So if it is a semicircle, the whole of this should be a right angle triangle. It should be 90. So if I have 58 there, then I'm going to have 32 as the side. So if I add it together, I'm going to have a 90. All right. If I have 90 here, I have 22 here. Then I can get my C2, because the total angle in a triangle is 180. So I have 180 minus bracket 90 plus 22. If I resolve it, I'm going to have 68 degree, and that is angle in a triangle. So that is for that. Very simple. Very, very simple. Please watch out for our next video. And please, we want to beg all our viewers to please subscribe to our videos on YouTube. This is a channel that is primarily designed to educate high school learners, to make them to be very good in mathematics. For students that are planning to study engineering, that are planning to study medicine and other sciences, I believe this channel is really going to be helpful to them. And even if you are not studying any science course, for you to be very good in your maths, please subscribe to our channel. You can share our videos to friends and loved ones. And we also hope to hear some feedback from you. Thank you very much. See you next time.